Thank you for joining in. This project is funded by the European Union Horizon program. Our webinar series Lessons Learned is a part of the Circ-uits project and contribute to the dissemination of our 3 years innovation action results. Please enjoy.
Good morning again, everybody. I'm Simonetta. I'm working from ERION, that is the PRO involved in this project. And I'm going to talk now about the Pilot 4 that is dealing with the end of life of the PCB, obsolete PCB. Specifically, is dealing with the tentative to create a reuse pattern and optimizing the clustering for the pre-sorting of the PCBs. Before to start, I want to discuss a little bit which one are the challenges of the end of life, starting from the collection deficit. Probably you already know that the ability to collect, especially in Italy, is not reaching the European target. So this is, of course, related with the availability of PCBs at the end of life. Then the recycling process that so far is not considering a systemic approach. It is focused only on precious materials, so it is targeting materials like gold, copper, and palladium, but not all the others contained in a PCB. And this is, of course, not allowing to be adherent with the new requirements of the CRM Act. Also, because the lack of technologies and the let's say the ability of the treatment plant to develop in a flexible way new processes. Of course, the market now and the European legislative panorama is pushing for the reuse of components, and to create new business model that allows the material to stay to be held in Europe. So we can see that there is a growing demand from the market, from the new legislative panorama like the ESPR, the Right to Repair Directive, and of course there is a couple of topics related with this. There is the cost of the new products related with the refurbished components, and also the needs for a shift from the design for obsolescence through the design for reuse and upgrade of components. What we are talking about, this is the environment. Let's say this is where the Pilot 4 is working on. What you can see here is the condition in which the washing machine are reaching the treatment plant. Why the washing machine? Because together with Beko, we decided to strategically design a pattern, a new way in order to detect and extract PCBs from washing machine from the end of life. So to assess if it's actually possible to recover these components from the end of life stage. What happens when a washing machine reaches the treatment plant? There is a first stage in which the machine is opened, and in this moment the operators are removing dangerous components and cement. And then there are a couple of fine treatments in which we can actually get the material that then will be separated through different technologies like the magnetic separation, the eddy current, and then the optical separation, in order to divide ferrous and not ferrous materials, and also plastics. This is instead the new pattern, the new solution that we are trying to propose. That is, of course, considering at the pre-treatment stage, the pre-treatment level, so just before the first treatment of the washing machine. It is considering to integrate digital tools in order to detect if a specific PCB it is reusable, it is fixable, and therefore it can be extracted before that the washing machine is entering the normal flow, the normal treatment flow. Of course, the washing machine focus is just in order to get some result on the project, but this is a process that might be scalable, so might be applied adapted to different products. What you can see here is two different streams, the one for the reuse flow and the one for the recycle flow. What does it mean? It means that if the PCB detected in the washing machine is the targeted PCB from the OEMs, from the producer, Beko in this case, then that PCB undergoes a specific flow in order to reach the producer, and therefore make some tests and fix the PCB in order to use it in a reconditioned product. But if the PCB is not reusable, this PCB needs to be classified together with all the other PCB reaching the treatment plant, and therefore at this stage there is the integration of another digital tool, the AI sorting, through an AI camera that allows to better sort the PCBs in order to keep the value, the economic value, but also in this project the tentative was to see if it was possible to cluster the PCBs to optimize, let's say, the treatment process according with the materials contained in the PCB. Moving forward, we can start from the reuse flow, and for this flow, together with Beko, we decide to target a specific components, that is the windy strip BPM. This is because it is the most used PCB in Beko. It is used actually in more than 500 models, and it is on the market already from 10 years. So it will be probably close to the end of life soon. And the price range of the components, of course, it's between 80 and 160 euros as a new part. And what was possible through the project was also to, let's say, highlight, to flag that one of the main gap, it is that a component that is exiting the end-of-life flow, it will of course cost more than a new component. So in order to make this business model, this solution ready for the market, it is needed, of course, to have some consideration on the whole stream in order to get components that has a cost that is available for the market. What we've been doing in the project, we involved a couple of treatment plants in which we ran some sampling campaign to detect if this specific components was in the treatment plant, was in the machine reaching the treatment plant, and which one was the condition. So if it was functioning or not, if there was major damage or not. This that you see here on the right are the requirements that we could use, and then in this picture, let's say, there is the parameters. So what we've been testing in order to detect if the batch was ready for the producer to be tested or not. Two batches were run. The first one on 100 machine gave us 40 boards, but only 4 boards were actually surviving the test, so were actually considered reusable. In the second batch, 1,000 washing machines were evaluated. Only 60 boards were, let's say, defined as targeted one, because between the first batch and the second batch, there was possibility to refine the requirements and the strategy for the operators to actually detect the right machines. But also in this case, only 7 PCB were found as reusable. There is of course quite good result, because the washing machine are young, so they are still on the market, and still we can find something in the treatment plants. So in the next 10 years, it is really possible that we will find more components like this in the treatment plant. What you see here is the first digital solution, that is the marketplace. The marketplace is meant to link, to be a bridge between the end of life and the beginning of life. And the idea behind is that wherever a component is found as reusable, as functional, it is possible to upload these specific components with the technical information and also the condition detected in the treatment plant, in order to inform the beginning of life about the possibility to buy spare parts from the end of life, and to therefore try to get, let's say, the components from this other stream, and then to repair products that are already on the market. So this is not meant to let's say make available components for the new product, but because of the certification of the product, it is possible only to integrate these parts in refurbished product. This is how the marketplace is supposed to work, together with a digital tool that is the Visux, that is allowing actually the operator at the treatment plant to see all the specific that are available on the marketplace, and therefore to target in an efficient way which product is containing the PCB, so that they don't need to dismantle all the washing machine, but just the washing machine that, thanks to different requirements and the machine code, is actually flagging that is inside the targeted PCBs. So for this solution, of course, there was another webinar also held by us, but in this case, TXT, that is the digital provider, the technology provider, was more explicit on the functioning. So there is also a video at the end of the presentation, a link to a video at the end of the presentation, in which you can see the demo of the whole product. And therefore, if you have curiosity on that, we can still address TXT for any further question. If we go in the recycling flow, what we've been scouting in the project is it is actually possible to improve the recycling process of this product in order to obtain new materials and to push the upgrading of the technologies at the treatment plant level. And this is what we discovered. Basically, we've been learning from the treatment plant the strategy for the sorting. So they explain to us which one are the parameters behind. For example, if you can see the gold with your eyes on the board or not, if there is some ceramic components on the board. All of these parameters are allowing them to have a clear distinction, almost clear distinction of which PCB should go under which flow. So the high value, the very high value, and the middle value. And we've been learning from them this strategy, and then we ran a couple of tests, one for the manual sorting and one for the algorithm that was trained through two different data set of 2000 pictures of PCBs. And so for the project, we've been validating the AI sorting, the algorithm, through a couple of tests. The first one was the manual sorting that allowed us to establish which one was the starting point, and then the AI sorting, with which we examined the same batch that the manual sorter was examining, and then we could compare the performance and of course learn how to improve the algorithm functioning. This is what we get from the manual result, from the manual sorting test. The sorter at the beginning of the process stated that his sorting process was accurate around 97%, but thanks to the tests, it was possible to assess that actually there are some underestimation and overestimation error. This means that sometimes, of course, some PCBs are not recognized as they should, so they are not reaching the right category. And this is actually a real problem only if we talk about the first four categories, so the really high value category that are underestimated and goes in the second choice board, because only in this case, the misunderstanding of the value of the PCB is actually creating a problem, an issue on the revenue of the project of the treatment plant. But in all the other cases, let's say that the value is almost the same. So in this case, is also thinking about the recycling process, it won't really be affected. But if the high value PCBs undergoes the second choice boards category, in that case, we start having some issues, some trouble. Then there is the result from the algorithm. You can see on the left this matrix, in which on the diagonal we can see the performance of the AI on recognizes specifically the category, so the very high value, the high value, and the middle value. Of course, what we've been learning is that it is possible to make more specific the algorithm. It is possible to give them to the algorithm a series of parameters more specific. For example, the ability of detecting specific components, but this is let's say a really long process, because of course the variety of PCBs is it's important. So for this project, what we've been doing is to basically select PCBs and allowing the AI to learn that kind of PCBs were part of a specific category. Therefore, the AI developed a mechanism to recognize PCBs in a statistical way.
Thank you for watching this webinar episode. If you're as passionate about sustainability and innovation as we are, here's how you can get involved. Stay connected with us on our social media and website for the latest updates and insights from the Circ-uits project. Whether you're an individual or an organization, there are plenty of ways to contribute. Reach out to us to learn more about partnership opportunities, events, and initiatives.